Hey everyone. I'm going to talk today about two algebraic rules for lines, and you need to know both of them, one more than the other. The one that isn't used as much in calc, you already know. I am videoing, so I can't really talk right now. I'm so sorry, John. So here you go. There are linear algebraic rules. Bam. So the first one is the slope-intercept form. Can you tell that these are notes that you should just be putting into your notebooks, right? Slope-intercept form. And you know it. It's our old friend y equals mx plus b, where the m is the slope and the b is the y-intercept. Shazam. Okay? Done. Now, if you have a couple, like what's going to happen in calculus is they'll give you a couple of points and you need to find the y-intercept. And it's really, the algebraic rule. It's really easy with this one, like if they give you the right points. Like if they say, oh, 0, 6, and I'm just making something up, 2, 4. Great. I can easily find the algebraic rule. First I find the slope, then I find the y-intercept, right? I've got 2 slots that I need to fill in, right? You need 2 slots for this one. So let's do it. M is going to equal 4 minus 6 over 2 minus 0. Negative 2 over 2 equals negative 1. So, and then I already know my y-intercept, right? Can you tell, like I was nice to you and just gave you the y-intercept here? So the algebraic rule would be y equals negative 1x plus 6. Shazam, done. But this one becomes a slight hassle if they don't give you the y-intercept. It's solvable. It's easily, like, you probably have found the technique. But if we did like 2, 6, or I shouldn't say 2, but like 10, 6 and 2, 4, then like it's sort of a bummer, right? And you have to solve for b if you remember how to do that. I'm going to show you a different technique also, a different algebraic rule, and this is the one that gets used all the time in calculus. So you know this one, slope-intercept form. The other one is point-slope form. I'm going to draw up here, point-slope form. Now, I'm going to show you why it works right now. Honestly, I mean, it's nice so the math doesn't seem like magic. You don't need to know why it works, but I think it's actually figure-outable, okay? So just check this out. Let's say that I have 2 points here somewhere, wait up. Let's say I have 2 points, so here's an example. Or actually, no, let's not take notes yet. I'm just going to show you how this works, okay? So don't write notes. Let's just do a little example. Let's say we have 3, 5 and 2, 4. Now, can you tell that I don't have the y-intercept here, right? Nothing there. But could I find the slope? Yeah, I still could find the slope. I just won't, mx plus b, like, is just going to be slightly more difficult. Well, let me find the slope. So m equals 4 minus 5 all over 2 minus negative 3. So that is negative 1/5. Okay? Great. So I'm going to reason like this, all right? Here's the part where if you understand it, great. If I have the point negative 3, 5, 1, 2, 3, 1, 2, 3, 4, 5, bam, and over 2 and up 4, 1, 2, 3, 4, bam, I have a line that looks like this. Do you agree? I'm just going to choose the point 2, 4 here to look at. All the line is a relationship between x and y, right? That's all the line is. It like over here, what's the relationship between x and y? Well, if you need y, you just multiply this x, whatever it is, by negative 1, and then add 6, right? Like it just shows a relationship. So that's all I need. If I can show the relationship between x and y here, I got my algebraic rule. So think about it like this. Hey, there's going to be some random point out here. Let's call it x, y, okay? Could be anywhere on this line. But I know one thing, that if I look at the slope between these 2 points, it should be negative 1/5. Agreed? Like the slope should be negative 1/5 all the way along the line. That's what makes it a line. So I'm just going to write down what I just said. My slope, negative 1/5, had darn well better equal this y minus 4 all over x minus 2. You see how I just found the slope there and set it equal to what I know the slope already is? And then what I'm going to do is I'm going to multiply both sides by this x minus 2. Because guess what that'll do to this fraction? It'll just make it go away. So I'll have negative 1/5 x minus 2, and that equals y minus 4. Let me flip this around here, because that's how you'll usually see it. Am I too low on the board? I'm getting kind of low. Y minus 4 equals negative 1/5 x minus 2. Folks, do I have a rule that shows a relationship between x and y here? I do. It's messy, but if I told you that x is, I don't know, 12 or something like that, could you figure out eventually what the y is? And then you'd have your point on the line? It works, right? It shows it. And actually, yeah, I think I am going to stop there. This is called the point slope form of a line because in this one you have 3 slots to fill in, not just the slope and the y-intercept. Here you got the slope. There's one of the slots. And then you need 1 point on the line. That's why it's called the point slope form, right? Because you need a point and a slope. But once you have those, you just plop them in here. Here is one, let's see, where was your point? Your point was 2, 4, right? And you see where the 2 shows up? Bam. And you see where the 4 shows up? Bam. So this turns out to be, mega important in calculus. This point slope form gets used all over, like literally for the next semester. We will probably use it, I don't know, probably on average once a day. So it's really good to know it. And the thing is, it's fairly easy. Let me do one thing here. I shouldn't have used, I kind of quartered myself into the board here, and now I don't have a lot of room to write. One thing I also want to show you is this. You might be like, wait a second, you had another point over here too. Negative 3, 5, right? Well, what if you would use that point, Mr. Ishida? You totally could. It doesn't matter what point on the line you use, because here's the thing. No matter what point you use, isn't the slope always negative 1/5? So this one totally works. It's completely right. Let me just erase here and show you that you could also be like, you could also say y minus, what's the first slot here? Can you tell? It's the y coordinate. So I'm just going to do the same thing here, the y coordinate, but I'm going to choose the 5 instead, okay? And then what's the second slot? It's the slope of the line, right? So I'm going to plop that in. Bam. And then I have x minus, and what's my last slot here? It's just the x coordinate, right? So I'll just use this, negative 3. Can you tell usually you would just write that as x plus 3, right? Anyway, this is also the same line. And, okay, I just got limited time here. I'm trying to think if I should really show you that these are exactly the same. Like, if I put this one in y-intercept form, slope-intercept. If I distribute this fifth, I'll have, plus 3, so minus 3/5. And if I add 5 to both sides, what is 5 is the same as 15/3, right? So I'll have y equals negative 1/5 x, and then, what am I doing wrong? I'm doing something wrong because I know what the answer is supposed to be. It should be 21/5. 3, that is negative 3/5, isn't it? And then 15/3 is definitely 5. If I add 15/3 to negative 3, I'm going to get minus 12/3. Okay, I'm definitely doing something wrong. I'm pretty sure. Let me just see if this, I don't think it's going to work, but it should. Okay, sorry, this is so sloppy. Negative 1/5, minus 2/5, right? And then if I add 4 to both sides, 4 is the same as 25ths. Oh my gosh, I am so silly. I needed, oh my gosh, oh my goodness gracious. You guys, I'm making a total jeepers creepers. Can I start over? Okay, this is right. What is 5? It's 25/5. Jeepers creepers, right? So if I add 25/5 to both sides, I'm going to get y equals negative 1/5 x plus 22/5. I think that's right. Please tell me it's right. Hello, where is it? I guess I don't have it on here, so we're just gonna hope that it works. Oh yes, it is. Okay, good. And then, so this is the y equals mx plus b form of this. I'm so sorry. And then if we do the same thing here, this is. Do you agree that this is what is 4 in terms of if I have to? It'd be 25ths, right? And if you add 25ths to both sides here, this would be a plus. Oh my gosh, this is horrible. I'm so sorry. If you add 25ths, you're going to get the same thing, okay? Trust me. It doesn't matter what point you use. That's the big thing. So here's what you should put in your notes after that butchering. So point slope form looks like this. And this is the algebraic rule that gets used way more often, okay? So point slope form looks like this. If x1 comma y1 is a point on the line, and m is its slope, comma, okay, oh, sorry. So, if x1, and notice I did it as subscripts, that's how you usually see it, x sub 1, comma y sub 1. If x1 is a point on the line and m is the slope, then the line's algebraic rule is y minus y1 equals m times x minus x1, Shazam, okay? And you've got 3 slots you got to fill in all the time here. You need to know the slope, and you need to know a point on the line, the x1, y1. In our case, we were using those 2, 4, and negative 3, 5, right? But I don't care what it is. Here, let's do one example, okay? Just because this is really important. A little lower on the board. Okay, so example. If, let's just do 6, negative 2 is on the line, and the slope is 7, then the algebraic rule is, yep, you're okay. So let's just follow this thing. We have 3 slots we got to fill in. So I'll have y minus, but what is my y coordinate? It's negative 2. Bam. Equals, oh, here goes another slot. Okay, what's my m? Oh, it's 7. Shazam. And then x minus, oops, what's my last slot here? Oh, it's just 6.
Do you know how much glue?
Okay, and can you clean this up? Yeah, you can. You can make this be y plus 2.
I'm going to need more glue.
Equals 7, x minus 6. And kids, just leave it like that. Could you put it into y-intercept form? You totally could. Do we? No, not usually. This will be a totally acceptable answer, okay? If you get this, that would be fantastic, okay?